Hi guys, welcome to my channel. Today we're going to be talking about permutations and combinations. I'm leaving it. I don't care anymore. Okay. So,
Hi, Jen.
here we go. Okay, so section 15.3 is starting like our second half of probability, and it's kind of similar to independent and dependent, how we had to decide like our solving strategy based on whether a situation was independent or dependent. Now we're going to look at two different types of combinations, and they're called permutations and combinations. So we're going to go over the definitions, practice it a little bit, and then hopefully as we keep going, the examples will help you. So a permutation is an ordered arrangement of items without repetition. So an ordered arrangement of items without repetition. I can never spell. So that means like order is very important when it comes to permutations. So we will look for problems where order matters, and that usually includes like specific jobs or titles. And once we define combinations, I'll kind of give you examples of both. So most important thing is that permutations, order matters. In combinations, those are an unordered collection of items. So that would be like just groups instead of an ordered amount. So on our first day of notes, we did the counting principle, and we had those situations where we had to decide, can we repeat numbers, can we repeat certain people or whatever in our example, or can we not repeat numbers, like those locker combinations and stuff like that. So it's kind of like thinking of those two differences. So a permutation, things can't repeat, so order would matter, and in a combination, we can't repeat items. Or we can repeat items, sorry. It'd be like a group of people. So this first example is going to be a permutation because it's the number of ways you could award first, second, and third place medals for the science fair. So what that means is if Michaela wins first place and I get second and Sarah gets third, that's one way we could win those awards. And I could use the same people but change the order. So let's say I get first place, Sarah gets second, and Michaela gets third. That's a second way. So that means order matters. I'm assigning a value to each spot. If it was just that the first, like the three people that score the most points, they win, that's just a group of winners, then if it doesn't matter if it's me, Michaela, Sarah, or Sarah, Michaela, me, the order wouldn't matter. Okay, so that's kind of what we're going for. Permutation, it's got a specific rank. Combination is just like a group of people. So that's what we're going to go through on this first page. The number of ways a committee of 3 could be chosen from a group of 20. You're going to see committee a lot. Think of group when you think committee. So the number of ways a committee of 3 could be chosen from a group of 20. Would that be permutation or combination? What do you think? Combination. Because that's just a group, a general group of people. The number of ways a president, vice president, and treasurer could be chosen from a group of 20. We have 3 specific titles that we're trying to fill the spots for. So that would be the permutation. So you'll see a bunch of different examples on this page of what that might look like. So if they're fulfilling a specific job, because it could be your president, your VP, I'm the secretary, or it could be me, you. There are 11 people on a baseball team. How many different ways can a pitcher and a catcher be chosen? That's a permutation because we have two specific jobs we're trying to fill. So the order makes a difference. There are 13 people on a softball team. How many ways are there to choose 10 players to take the field? That's a combination because it's just a group of 10. It doesn't matter what order we put them out there in. It's just whatever 10 people. There are 5 people on a bowling team. How many ways can you choose your bowling team captain and team manager? That's a permutation. Good. And then a pizza parlor has a special on 3-topping pizzas. How many different special pizzas can be ordered if the parlor has 8 toppings to choose from? That's a combination. So that one's a little different than the ones we saw above. That would be saying a pizza with pepperoni, olives, and peppers is the same exact pizza if I said olives, pepperoni, peppers. Same pizza because they have the same toppings. So it's just like the groups. Find the number of possible committees of 3 people that could be chosen from a class of 30 students. So that's a combination. We see that committee word again. So that makes us think of just a group of people. Okay, so that's the general sense of what we will have to decide for in order to figure out how to solve these problems coming up. All right, and we're going to go over permutations first. So I think this part's super helpful in the notes because we are going to highlight some keywords for problems that are going to use permutations. So some keywords you might look for is if we are talking about an arrangement or how you can arrange different people. That means like put them in first, second, third place, stuff like that. If it talks about the order, like the order matters, like I said before, if they say first, second, third place, or we really like to use the president, vice president, secretary, or treasurer, or whatever, and they could have more than 3 titles. Basically anything where you have specific options. They give you like very specific spots that you're trying to fill those people in. My absolute favorite part about these is that the calculator makes it super easy. So this first example says the environmental club is electing a president, vice president, and treasurer. How many different ways can the officers be chosen from the 10 members who are running for office? So when you're reading the question, you should be looking for the total amount, which would be 10, like how many people you have to choose from. You should also look for how many spots you're trying to fill. So for this one, we're filling 3 spots. And since order matters, we pick permutation. The calculator will do that for you. So if everybody will get their calculator ready. The first number we're going to put in before we do the fancy stuff is the total that we have to choose from. So since we have 10 members, 10 will be first. Then we're going to press math, so the button right under alpha, math. We're going to go to our probability over there, the PRB, 10, and then math. Arrow over to PRB, and then it's the second one, NPR. So N is the total number, P stands for permutation, and R is like the number of spots we're filling. And so that's 3 for this one, and then you'll just hit enter. So we have 720 permutations that are possible for this example. There's like 720 different ways we could get president, vice president, and treasurer. So this whole page is going to be permutations, so there's not really that deciding factor yet. But we're just going to go through and like practice typing this in, get that muscle memory of where the buttons are. So how many different ways can you arrange 10 DVDs on a shelf? So 10 is our total. We have 10 DVDs to choose from. No, that was just a coincidence. We have 10 to choose from. We're going to write P next because we're using permutations. And then if I have 10 DVDs, how many spots am I trying to fill on my shelf? 10. Since I can't use one DVD in multiple places, that's why there matters. So that's why it's a permutation. So we will do 10, and you can just bring your one you just typed in back up and change the second number if you want to. It is over. 3,628,000. So lots of possibilities. Please make sure that when you get to your homework and stuff, so I would do it now too, make sure that this is what you're writing every time so I can see what you did. How many different ways can 5 students stand in line in the cafeteria? So 5 is our total, and then we want permutations of how many spots are we filling? 5. So they won't always be the same number at the front and back either. It just depends on the kind of problem. So that would be 120. During the X Games, 14 athletes are competing. In how many possible ways can the athletes get gold, silver, and bronze? So we have a total of 14. P, and then what number should I put next? 3, because we have 3 medals. So we would have 2,184 possibilities of an order for those medals. Last one, you download 11 songs on your iPod, because we still have those. If you select random shuffle, how many different ways could the 11 songs be played? So 11 songs, it's a permutation because I'm not considering I could play the same song twice. So the order matters again. And then we would get a giant number. Oh, I don't know what I just did. A weird 8. So remembering that order matters for permutations is going to be super important. Now we're going to do the combinations practice. And we're going to start with keywords. So keywords for combinations. Group is the main one that I would look for, and probably committee. We do a lot of committee problems. Remember, those basically mean the same thing. Let's see, we put select earlier, so if you're just selecting 3 people or select of 4. And choose. Basically, anytime there are no specific order. That's when we'll use So our example for this first one is there are 8 seniors on a football team that are being considered as team captains. If there will be 3 team captains, how many different ways can the seniors be chosen as captains? So just choosing 3 people. Order doesn't matter. We're going to set it up exactly the same way as permutations. The total goes first, and then how many we want in our group. And your combinations button, you probably saw it earlier, is that NCR in the probability section. C stands for combinations, so it should be easy to remember. And we would have 3. So there are only 56 different combinations of that example. Okay. Your English teacher has asked you to select 3 novels from a list of 10 to read as an independent project. In how many ways can you choose which books to read? So how many total novels do we have to choose from? 10. C goes in the middle, and what's our group amount in the group? 3. So 10 combinations of 3 is 120 total. There are 30 students in the classroom. 6 of them are to be chosen to clean up the room. How many different ways are there to choose the 6 students to clean up? So we have 30 total. C is in the middle, and we want 6 of them to clean. Don't we all? So 5, 9, 3, 7. So there's a lot of definitions for our students. A professional basketball team has 12 members, but only 5 one time, because that's how basketball works. How many players can be court one time? So what is this going to look like? 12C size. And did he tell me it? Thank you. What? The last one is where it gets a little more complicated. Not bad, just a little bit.
They're saying these are how many possibilities you can have, like, different groups?
Yes. You don't? Should we write them all out?
Put 6 of those in a group, put all of those in.
But it means, like, it could be U6 or U5 and a different person, or U5 and another one, or U5 and then it could be then it could be U5 and one other person. So like it's all the different ways you could just change one single person, it adds up to that many. So we could do that on paper and like try to figure it out, but I think that would take us to the end of the year. So we're not going to do that. But yeah, that's how it works.
I thought it meant all 6 people have to be different.
No. It means just like one person changing each time. Yeah. Good. Okay, a committee of students is to be formed to decorate the gym for homecoming. If there are 250 freshmen, 230 sophomores, 225 juniors, and 205 seniors, and the committee must consist of 3 members from each grade, how many committees are possible? We are actually going to multiply them together. So in all of our like compound probabilities and counting principles and stuff, we've multiplied when we've had multiple things. So it should be pretty easy to remember that we're going to multiply those together. So we are going to start with our freshmen, and we have 250 total combinations of 3. Now we have to do the same thing with sophomores. And we're all going to type it in to make sure we get it typed in correctly so everybody sees what that looks like. So it's a little rowdy just because it's a lot of numbers. Oh, my calculator. Okay, so sounded like a duck. You guys all know that you laugh when your calculator makes that noise. I hit enter a little early there. I'm distracted. Okay, so remember we talked about when you see E, I think we talked about it in here, when you see E, that should make you think of scientific notation. So we're going to use our 1.36 times 10, and then this E is telling you what the exponent is. So 25 should be the exponent. So that means this number is giant. That means that we would move that decimal place 25 times to the right, which is crazy. Because if I pick one combination of these people, it could be with any of the combinations from the other group. And then I pick a different combination, we multiply them all together, so it gets huge. You probably won't have to do a ton of those, but just be prepared. We might have you like multiply 2 together instead of to get giant numbers. Okay, so the next page, we're going to go through this. It probably will go pretty quickly. This is where it's all mixed together. It's going to be like your homework. And so we need to decide if it's a permutation or a combination. That's the main thing. And then we'll set it up and type it in. The ski club with 10 members is to choose 3 officers, captain, co-captain, and secretary. How many ways can those offices be filled? So which type would that be? We're just going to say P or C?
P.
P. So we have 10 members, and we have 3 spots to fill. We've done that before, I think, maybe. 10 P 3 is 720. To win the small county lottery, one must correctly select 3 different numbers from 30 numbers. The order in which the selection is made does not matter. How many different selections are possible? That is C. Order does not matter. Oh my gosh, totally this.
Can they hear us?
Probably. Either that or they think I just said probably to myself. C 3 40 60. You are on your way to Hawaii, and of 15 possible books, your parents say you can only take 10. Wow. Interesting vacation. How many different collections of 10 books can you take?
So that's gonna be P. I mean C.
It's gonna be C, or it doesn't matter.
It's going to be C. Order doesn't matter. 15 possible books. C. We have 10 spots to fill.
I understand.
Okay. What do we get?
Hold on.
They hear this like you're asking them what do we get? Like a door.
3,000 is
Did you find that?
I'm pretty sure that you can hear. For a segment of a radio show, a DJ can play 4 songs. If there are 8 to select from, in how many ways can the program for this segment be arranged? Before you shout it out. That means that they're saying, since they use the word arranged, that the first song, that the order matters, is basically what they're saying when they use the word arranged. So I don't think we've seen that example yet. So that would be a permutation. If that's what you were going to shout out, then good job. We have 8 songs to choose from. 8 P4. Well, this is geometry. What'd you get?
1680.
Is that really what you got?
You did it wrong.
Oh, I was looking at the wrong number. We're good. The next one's similar. That's why. In a production of Grease, 8 actors are considered for the male roles of Danny, Kinnicky, and Marty. In how many ways can the director cast the male roles? So they have specific assignments, so that would be a permutation. There are 8 actors, and there are 3 spots to fill. This is the one I was looking at.
Those aren't even similar.
This should be 336.
It doesn't look like 1680.
Correct. I was looking at 8P4 and 8P3, and yeah. 7 bands have volunteered to perform at a benefit concert, but there is only enough time for 4 of the bands to play. How many lineups are possible? So lineups means how many orders are possible?
So then P.
So P. And we have 7P4. 8:40. Last one, a 4-person committee. That should already kind of help you figure out which one it's going to be. Is to be elected from an organization's membership of 11 people. How many different committees are possible?
So 11C4?
Yes, 11C4. 3:30. And that's it. So, main thing is to remember when order matters and when order doesn't matter. Make sure you practice it in class today because you have calculators. And that's it. Thanks for joining us. Bye.